If you're building anything with AI, you know this feeling all too well. You spend all this time creating an amazing coding agent. You get it working just right, and then boom, the ground shifts. A brand new model drops, and that treadmill just starts right back up again. So today, we're going to talk about how to get off that treadmill and start actually future-proofing the AI agents we're all building.
I mean, seriously, if you're a developer in this space, this has got to feel familiar, right? You build this incredible agent, it's working perfectly, and then the next even more powerful model is announced. And all of a sudden, it feels like you're right back at square one. You're just running as fast as you can to stay in the exact same place. So why? Why does this keep happening?
All right, let's dive into what we can call the constant rebuild problem. The insane pace of AI innovation is awesome, but it's also a double-edged sword. For us builders, it means the ground is literally constantly shifting right under our feet.
And this really gets to the heart of it. This is the painful reality. When a new foundation model comes out, it's not like you can just slot it neatly into your old system. Oh no. You have to go back, you have to retune all your prompts, re-engineer your workflows. You basically have to rebuild your agent from scratch to work with the new model's quirks. It's this massive recurring tax on actually getting anything new done.
Okay, so if we're going to solve this, we need to figure out exactly where the problem lives. So let's pop the hood on a typical coding agent and really find the one component that's causing all of this friction. So when you break it down, an agent really has three main parts. First, you've got the user interface, the command line or the IDE that you're actually interacting with. Then you have the model itself, the AI brain that's doing all the heavy lifting. But connecting those two is this absolutely critical third piece, and it's the part that causes all the trouble, something we're going to call the harness. So what in the world is this harness? Well, think of it like mission control for the AI. It's the part that takes your request, bundles it up with the right tools and the right context, prompts the model in just the right way, and then it has to translate the model's output back into a real, concrete action. It is the critical interface layer, and it's where everything gets really, really tricky. And this slide shows you why it's so hard. Building a good harness means you are constantly wrestling with these unbelievably complex problems. You're fine-tuning prompts for every single new model. You're managing how long a user has to sit there and wait for an answer. You're figuring out how to cram massive code bases into a limited context window. Oh, and you're trying to teach the model how to use tools it has never ever seen before. It is a full-time job, easily. Now here's where it gets super interesting, because this gives us a huge insight into why prompt engineering is so hard. See, a model has two different qualities. On one hand, you've got its intelligence. That's the raw knowledge, right? The coding languages, the frameworks it knows. But then there's its habit, and that's the specific way it was trained to solve problems. Does it like to plan everything out first? Does it prefer gathering a ton of context? Your harness has to align with its habits, not just its intelligence.
And this story just perfectly nails the point. The team at OpenAI was really struggling with slow performance on one of their agents, so they just asked the model directly, hey, what's wrong with our prompt? What can we do differently? And the model's response was basically, look, your instructions are fighting against my natural habits. You're forcing me to be inefficient by looking at everything when I don't need to. This just shows you how deep that connection between the model and the harness really has to be.
Okay, so all of this brings us to a totally new way of thinking about this, and it's best shown by OpenAI's Codex platform. The core idea is actually pretty simple. What if the model and the harness weren't two separate things you had to jam together? What if they were designed from the ground up together as one single integrated unit?
Right. This is the fundamental shift in how we build these things. The old way, on the left, is just a constant maintenance headache. You build your custom harness, you connect it to some separate model, and then you spend all your time patching and maintaining that fragile connection. The new way, with a platform like Codex, combines them. The model and the harness are co-designed to be perfectly in sync, and the best part, the maintenance of that connection is handled for you.
So what does that really mean? It means all of that nasty, complicated plumbing we were just talking about, it's just done. Things like managing a bunch of tool calls at once, or handling security and sandboxing, or figuring out the best way to optimize the context window. It's all built in. And that frees you, the developer, up to focus on what actually makes your product special, not on resolving these huge engineering problems over and over again.
So what happens when you finally get off that maintenance treadmill? Well, you can start exploring totally new ways to build things. And this isn't just about saving a little time. It's about unlocking brand new capabilities that just weren't possible before. This right here is the key takeaway. That integrated harness becomes your new platform, your new abstraction layer. So instead of building on top of a raw model, you're now building on an agent-native foundation. And this lets you pour all of your energy into what really matters. differentiating your product and making an incredible experience for your users.
And we're already seeing these really powerful patterns emerging from this new approach. Developers are using SDKs to call these agents programmatically. They're automating super complex CI/CD tasks right inside GitHub. You've got companies like Zed building these beautiful custom editors just by wrapping the core agent logic. And for total control, teams like Cursor are even forking the open source harness to deeply integrate their own custom tools. It's amazing.
Okay, and this is where my mind was kind of blown. Because the foundation is so solid, you can create agents that are truly dynamic. I mean, just think about this for a second. You can give your agent a tool that allows it to create new tools on the fly to solve problems it's never seen before. We're going from static toolboxes to self-expanding, self-improving agents. It's wild. So what does all this mean for the future? Well, by building on this kind of integrated foundation, you're not just solving today's headaches, you're actually getting yourself ready for whatever's coming next. And the momentum here is just undeniable. This integrated approach is already scaling like crazy, serving dozens of trillions of tokens every single week. This isn't just some theory. This shows a really clear direction for where the whole industry is heading.
And as these models and their harnesses get more and more capable, something really important starts to happen. Our trust ceiling begins to rise. Think about it. 6 months ago, maybe you only trusted an agent to write a small function while you watched over it. Today, maybe you trust it to refactor a whole file. In the future, that trust is going to extend to much bigger, more complex, and totally unsupervised projects.
And this is the kind of stuff we can expect to see. We're talking about agents that can navigate these massive, sprawling, enterprise-level codebases. Agents that can actually understand your company's proprietary, closed-source libraries. And this is huge. Agents that can learn from their own mistakes and not repeat them, and that can tackle problems that take hours or even days to solve, not just a few minutes.
So we'll leave you with this one question. When you don't have to worry about that constant rebuild cycle anymore, when the prompts and the tools and the context are all managed for you, when all that painful plumbing just works, what incredible things will you be free to build? Thanks for joining us for this explainer.